Right. Good afternoon. My name is Gordon, and thank you all for being here. Today, for this talk, I'm going to be talking about managing state in Apache Flink. And I actually find this a good follow-up to the last talk, which was Robert, who was talking about operational aspects of Apache Flink. Now, I'm just going to focus a bit more on state management on Apache Flink. So first of all, as usual, it's not responding. OK. So first of all, as usual, a shout out to my employer, Data Artisans. It was founded by the original creators of Apache Flink. And as all of you might already know from various sources by now, we are the providers of a DA platform too, which includes the open source Apache Flink and the DA application manager for the management of the lifecycle of streaming applications. OK. So today, I want to actually start, before actually getting into the technical details, I want to recap something that has actually been emphasized throughout the whole day, throughout the sessions, starting from the welcoming keynote, is that users, throughout the transition of Flink with the stateful stream processing capabilities and the use cases that are built on Flink, a common pattern that we're seeing as developers, as users also, is that users are placing more and more of their most valuable assets within Flink, which is the application data. And perhaps some of the most referenced application use cases is this Drive Tribe use case, which they actually gave a talk about earlier this morning. So what you can see here is that, just to recap this, they built a command query responsibility segmentation model on Apache Flink. And it's Apache Flink directly at the center of the whole infrastructure, where you have a Kafka source for the single source of truth, the ground truth, the event logs, and the stream processor, which is Apache Flink, consuming this log and manipulating the state, keeping all the application state within Flink. And basically, the servicing layer is just mirroring this state external towards Flink to these servicing layer Elasticsearch Redis for the end services. And so this basically brings us, again, back to this, this diagram here. This diagram here. So we're basically seeing more and more applications moving from the classic tiered architecture, where applications share shared state in a single database or multiple database, whatever, to this streaming architecture, where we're using streaming frameworks like Flink to host the state, keep the state within the computation, and keeping it near the computation for isolation, for performance issues, etc. Now, this wave of change is all centered around how Flink handles snapshots and how users are using snapshots to realize these infrastructures or architectures. And so this is just a slide to just recap the main strength and advantages of Flink's snapshots model. Now, the question to answer to follow is, as these applications are maturing and people are really placing Flink at the center of these architectures, and basically kind of, you can think of it as they are replacing databases in conventional architectures. So as they do this, they would also expect equivalent state management features as they would on databases or similar stuff. So as developers, the community are really trying to ensure that users can entrust the state within Flink. And also, more importantly, is the quality of life when you're managing these states. So when we come to this, the usual questions that people start to ask when they start thinking of this is, so as usual, not as usual, so as followed, some questions that I've collected throughout answering a mailing list or talking to people is, what are some of the best practices when you're declaring your state? And how is my state serialized and persisted? if you're going to trust everything into Flink, you would want to know how it is serialized. And also, if I need to change my serializer sometime, maybe because of efficiency issues, how can I adapt my state to be serialized by the new serializer, etc. And more importantly, when we are putting application state in Flink, the data model of that state would also change over time as business logic changes. So how can I change the data model or schema of my state? Disclaimer, first, these are questions that are constantly being worked on, and some of them are addressed, and some of them are still work in progress, or the discussion is still going on in the community, which I'll point out when I reach to each one of them. So the main thing about my talk today is answering these questions for you. Right. OK, so first of all, let's recap how Flink manages state for you. The basic ideas, the main ideas at a high level. So in your code, in your distributed code program, you would write for each of your operators, you would here, as you might be familiar with already, would declare some state. Now, this declaration would consist of two parts. One is the description of the state. So the description of a state, the descriptor, would contain at least a unique identifier. Okay? Now, this identifier is important because when you're restoring the program from some save point or from some state, each operator would use this ID to fetch that state to fill in. And then the second part is you're providing some type information about this state. Now, this is the most simple case where you just provide the class of your state type. As you'll see in the further slides, there are other approaches to this, but this is the basic approach. And then you would actually access the state. Now, the first time access, you would call something like get runtime context and then get the state. And the first get would actually register the state with the local state backend. So now the local state backend has registered the state. And then your consecutive, afterwards, when you start getting values from the state or updating state through the state handle, this is actually just read and write through the local state backend. Okay? The next part would be checkpoints, to know would be checkpoints. So what happens, this was just a figure of a single local operator. Now the whole picture would be each state would form together a complete checkpoint. So checkpoints are formed in Flink by pipeline checkpoint barriers, which flow throughout the whole topology. And when each operator gets this checkpoint barrier, the operator will synchronously snapshot this state to a distributed file system. And this is done asynchronously on pipeline, so there's no global stop in the whole topology when this happens. And this is very important because this is a streaming application. So the checkpointed state lives inside this distributed file system. Now, next of all is the restore. So when something bad happens, an operator or task breaks down, we need to restore the state, right? So each state would get their corresponding file handle, and then they'll stream from this file handle, read the file bytes, and then restore the state back into their local state backends. Okay? Now, a little bit more detail. Depending on the state backend, the serialization behavior would be somewhat different. Okay. So, for example, for the JVM heap backends, for example, for memory state backend or the file system state backend, the behavior in somewhat terms that we use is lazy serialization and eager deserialization. What does this mean? So, when you get records and you need to manipulate the state based on this record, logic on this record, every read or write you do, it does not go through serialization or deserialization when the state backend you're using is JVM heap. It's just Java object manipulation. When you actually do the checkpoint and when the operator stores this back to the distributed file system, then there's serialization happening. Okay? And when we're restoring, this is why we call it lazy, because we only serialize when the checkpoint actually happens. Now, eager deserialization is as soon as we restore, we deserialize all the state bytes back into Java objects and put them into the heap. Now, out of core support state backends, which currently we only have RocksDB. RocksDB state backend, it's the other way around. It's eager serialization and lazy deserialization. So for every record, for every read and write or update to the state, you would get a serialize and a deserialize. But when you actually checkpoint each state, these are actually only an exchange of state bytes to the distributed file system. Okay? And when it's restore also, why do we call it lazy deserialization? It's because we just restore these state bytes to the RocksDB local state backends. And when we are actually accessing, when we are using get runtime context, get state, and value reading or writing it, then the deserialization or serialization actually happens locally. Okay? Now, moving on to things I want to cover in this slide, in this talk. So, first thing I want to cover is state declaration. It's actually something that people who is new to Flink or new to stateful stream processing, well, Flink API itself, might sometimes get wrong. So the first thing is actually you should be aware of a state structure that you're actually using. And this depends on the access pattern of your state, how you access your state. So let's say this is something you should not do. So let's say you're declaring a value state, but this value state is keeping a map with string as key and mypojo as the value. But your access pattern is actually all you want to do is sometimes you want to update some key in this map, and then you just want to update this map afterwards. Okay, so this kind of access pattern, you should never do a value state, because what this does, state value, state update, is a whole serialize and deserialization of the whole map, especially if you're using RocksDB, for example. So you should always use the corresponding state structure of your what your business logic requires. So here we could see map state descriptor is the corresponding structure that you would be using, and this, every time you update this map state, you're only updating one single key. Okay, so and there's other different kind of structures available in Flink. This is just one of them. There's others like map state, list state, value state, as seen before, and others. They can be seen on the documentation. Right. Now the next part is declaration timeliness of your state declarations. This is actually, we must admit, this is actually kind of a flaw in the API design when we were thinking about the API for the stateful stream processing. And I'm pointing it out here because there will be potential changes to this in future releases. But here's just to point it out. OK, so first of all, you should try registering your state as soon as possible. Now, as soon as possible, we should, to be straight, it would be typically recommended to register it in the open lifecycle of your operator, if possible. We know that there are some applications that might not be able to follow this pattern, but this is basically what it means. So the flaw is in that right now, you can register a state anytime during runtime. You might have already noticed this if you are if you have already started to write Flink applications. So get runtime context, get state, and you provide this descriptor, which contains the accessing ID and the type information, etc. And then you can just get the value anywhere during your map process function. So what that actually means, if you think of it, is that you might not get your state registered until some record actually comes in, but the job has already started. Okay, this affects a few aspects. Just for example, if you have declared your state to be curable, then on restore, that curable state would not be visible until this is actually registered sometime in runtime. Okay, so this is actually the major flaw that I've been talking about, and the Oh, and this is the recommended way that you should, right now you could actually try to see if your application can be modified to this particular pattern. So you have your state handle here, but you initialize it in the open method. And then in the rest of your function or your operator code, you can just use it through your initialized state handler. Okay, so the direction that this state declaration is moving towards to is actually eager state declaration. Now, with this eager state declaration, what this would mean is that when the job graph of the topology is built, each operator would already know what state has been declared, as compared to this approach, which when the job graph is built, we have no idea what is built. This is only known at runtime. So the main thing that this allows is that the job manager would then have knowledge of each operator and their declared state within each operator. Now, the API looks something like this. It is laid out in this flip document. If you're interested, you can go check it out there. But the main idea is something like this. But take this with a grain of salt, because this is all under discussion. And there's already a few big users that are participating in this discussion. And we're trying to figure out the best approach if we're going to rework this. So it would look something like this. You would just annotate your state field with, let's say, keyed state, and you state the state ID and the curable state name, which is the state handle ID. And you override the map processing function, and in there you can just use state to do read and writes. Okay? And this actually looks quite nice, because it looks actually more intuitive to what we feel as local variables as state, but they are managed by Flink. Okay? And this is more of a sugar syntax for the users, who are directly programming on Flink. But there's also another set corresponding to this, which is programmatic, so that layers on top of Flink, such as Beam, can also use this feature seamlessly. Okay, just something to keep in mind for future releases. And the next part I want to go into is state serialization. Okay. State serialization, a lot of people ask, so I declare my state, I give it some information, I give it ID, and then somehow magically Flink serializes it for me and backs it up in the file system. So how exactly is my state serialized? I want to know that. And basically what happens is, if you recall, when we are declaring the descriptor, we provide it with some type information, which here is the class. And this type of information is analyzed by Flink's own serialization stack. And this actually just generates a tailored, efficient serializer that Flink generated to serialize the state when serialization is required, which I stated before. It's different timing for different kind of state backends. But the supported types, which Flink can recognize, can analyze, and can generate serialized for them, are these listed types. For primitive types, tuples, Scala case classes, and POJOs, which is a very nice thing that I would definitely recommend using, and which a lot of users are using POJOs. And all non-supported types, which I may have missed something, but all non-supported types which is not listed here will fall back to cryo-serialization. Okay? So, but one thing to be careful is that we should always try to avoid using cryo for state serialization and deserialization. Cryo may be used for internal transmission of data records, the serialized using cryo maybe, but when we're talking about state persistence, we always want to avoid cryo, because when we're persisting the state, which is the save point we're talking about, we might be accessing it again some point later, future in time, which the serialization scheme might have changed, whatever. So for this, cryo is not a suitable serialization framework for this particular purpose, as it has unstable binary formats, and it has an unfriendly support for schema evolutions. What we would recommend to use is actually frameworks like Avro or Thrift, which has a good story for schema evolution. And but the thing is, so your type has been recognized by Flink, not recognized by Flink, and it falls back to Cryo. And what you need to do if you want to use Avro or Thrift to actually serialize them instead of using Cryo's serializers is what you need to do is something like this. So you basically just register that type with a custom serializer. Now, there's some built-in custom cryo serializers that are shipped by Thrift or the corresponding frameworks, and which you can just basically use. This is just one simple case. For the whole full case on actually how to do this or the dependency to use, you can just see, check out this documentation. Okay. Now, if you want to skip Cryo completely, or let's say you want to skip, you don't want to let Flink analyze your type for you, you know how to best serialize your state. If you know how to do that and you want to do that, then this is also possible. And this is basically just done by you provide this custom serializer that you write. And this custom serializer has these read and write methods that you would need to implement. But this is basically what you do. Right, and moving on to the last part of this slide is state migration. So we're thinking about serializers, we're accessing, registering serializers for our state. Now what happens if on our restore of a save point, we registered a new serializer here, but this serializer cannot read the old data. But you want to change the serializer because you know it's more efficient if you do the change. So what happens here is that Flink provides some hooks, you could say, to let you do upgrades to the serializing schemas or schemes. Or you can actually change the schema data model of state types. Disclaimer, as in this is not available yet in 1.4. What is available in 1.3, which is as of now, is you can upgrade your serializers if and only if it is compatible with the previous serializer. Okay? Now, an upgraded serializer, there's two cases actually that you might bump into where your serializer is actually upgraded or modified. The first here is you actually changed your MyPojo class, and the generated Pojo serializer is actually different from the time that the save point was taken. Okay? This is one case. The second case is you just have a new serializer. You just have a new custom serializer. And for these Flink-generated serializers, let's say you just use mypojo.class and Flink generated your serializer for you. How Flink performs the serializer upgrade is that at the time of a save point, it would store information about this serializer along with the state data. Now, this information would basically, for example, the Pojo serializer, it would say, OK, I'm serializing A first and then serializing B next. OK? Field A first and then field B next. And when you register the new serializer at restore time, which is a new Pojo serializer, which the fields might be out of order, the new serializer would fetch this metadata stored in that save point and then reconfigure itself to be compatible. So it will reconfigure itself to be the correct ordering of the fields. This is just a simple example, but all the Flink-generated serializers has this built in. So it can perform upgrades seamlessly. But if you're using a custom serializers, what you need to look out for is you'd also need to implement these two hook methods, which is snapshot configuration and ensure compatibility. Now, these two methods basically just corresponds to the two operations that I just mentioned here. So here, serializer to the metadata, this is exporting out your snapshot configuration. Okay? And this configuration, feeding it back to the new serializer and reconfiguring is done inside the ensure compatibility. Right. All right, closing. Okay. So basically, the Flink community, all these features that we've mentioned today, we take state management in Flink very, very seriously. And we always try to make sure that these state management features are you're comfortable with it, and you're comfortable with placing all your state within Flink. And upcoming changes or features to expect for state management would be eager state declaration and also state migration. Right now, you can perform serializer upgrades as long as it is compatible. If it is not compatible, then state migration is required, which is not available yet. But something to keep in mind. I think we have time for questions. So, yeah.
Hi. With regards to state management, is there anything being taken into consideration for GDPR requirements?
I'm not familiar with that. Could you explain?
Yeah, this was mentioned in the keynote. There are regulations in place with
ING,
how you use customers' personal information, and that they then should have the right to have their data deleted. Their data should be encrypted, and a number of other security aspects to it.
So this would require you're able to just go into your state or save point and then manipulate or maybe delete a record or a key.
Yeah, pretty much.
This is definitely not available right now, but there is some features that we have been considering, the community has been considering, like save point inspection. You can just query the save point and check whatever you want to query. And the removal of key of a specific key, I haven't actually heard about this yet. But what you can actually just do is you have a job that does this. You restore that save point, you delete it, and then you just take a new save point. Well, this is just one way to do it, but I can keep this in mind and discuss with you afterwards.
Yeah, if you could, that'd be cool.
You mentioned to avoid using cryo for serialization. So why is it the default? Shouldn't it? I'm just curious. It seems like if that really is an issue, maybe something else should be used. Or is it?
One thing to know is that the serialization stack in Flink actually existed a long time ago. It started when Flink actually only had the batch APIs. Now, in the batch programs, using cryo isn't a problem because your batch ends sometime, and you would not be persisting some state, and you would not be keeping it for further use, right? So it makes sense to use cryo. Now, in the state management API here, we're basically reusing that serialization stack and using it to generate efficient serializers. So cryo is still the default, but when it is used as state serializers, we would recommend to not use it, not use cryo. But this is kind of a historical development, I would say, from my point of view. Yeah.
Are there plans to change it, or?
Well.
Or does that? It sounds like you're saying that doesn't make sense.
I'm not aware of actual solid plans yet, but it would make sense, I think. Maybe, but we can keep this in mind.
Okay.
Good points.
Thanks.
Yeah. Right, thank you.